class is all about. So we are going to practice more of the maxima and minima.
Sir,
Yes.
so when you record this lecture, you upload it in YouTube, no? So, sir, what is the link?
When I record lecture, then Amit sir, and he uploads on the YouTube. So from there you can watch it.
Okay, sir.
Yeah. There is an official channel of Science Academy. You can watch it there.
Okay, sir.
So problems in maxima and minima. So what we have seen that every mathematical expression represents some geometrical picture which we say graph. Okay. So when we have a mathematical expression in which we have one is called dependent variable, other is called the independent variable, and when you plot that graph, I mean like that equation on a graph, then you see some geometrical shape, and you may see some crest, you may see some trough. So the localized crest and trough are called the local maxima or local minima, and we have a mathematical way to arrive at those points without actually looking at them. So even though we do not have the I mean the graphical representation in front of us, but still we can see those things mathematically by differentiating the function and equating it to zero. So every question of maximum minima begins with first step is creation of the mathematical expression in which one is the dependent, other is the independent variable, and from there you try to maximize or minimize something. So what we minimize or maximize is called the dependent variable, and therefore we must differentiate the dependent variable with respect to the independent variable, and we equate to zero. And when you equate to zero, what you get is called the critical points. So let's say when we have a question y equals to f of x, so y depends on some value of x in some certain fashion. So for critical points, now what are critical points? These are the points at which there is a possibility of either a maxima or a minima. So either of the two may happen. And how to get the critical points? So critical points are the roots of the equation. So critical points are the roots of the equation f dash x equals to 0. So when you equate, when you differentiate f with respect to x, the y, and equate to 0, the solution of this equation, I can say roots of above equation gives critical points. So roots of above equation gives critical points, and then you double differentiate. If you remember, we had written the condition. So for maxima, the double differentiation of the variable at critical points, which we have got above, should be negative. So if you substitute the critical point instead of x in the second derivative, and if it turns out to be negative, then you are going to get a maxima. And for minima, the value of second derivative at critical points must be positive. So these are the some finite steps which you need to follow to arrive at the answer. So let's see some problem which is
So what is
related to the
critical points?
critical points are the points on the x-axis at which the slope of the graph is zero.
Yes, sir.
So that is the critical point, and we have discussed about the same in the last lecture. So okay, it is like okay, if you have forgotten this, so no problem. So I'll just do some
No, sir,
random
I have
graph.
wrote it, but means my definition was not clear. That's why I asked.
So these are critical points, like the tangent where it is zero. So the point is on the x-axis, right here. This is critical point. This is y. This is x. So all these are critical points. So you have to what you have to do is you have to first double differentiate and you have to substitute the value of x in the double differentiation function and see for yourself whether it is positive or negative. If it turns out to be negative, it means you are at the local maxima, and if it turns out to be positive, you are at the local minima.
Minimum.
And if it is zero, you know what happens. If it is zero, then that's called the point of inflection. Okay. So if
Yes.
double derivative at any given critical point is zero, then so I can say for point of inflection. And what does it mean is graphically that the curvature will change from either convex to concave or vice versa. So point of inflection we have discussed. It's a point at which the curvature will change from convex to concave or concave to convex. So that property is called inflection property. I mean, say that point is called point of inflection, and beyond these two, I mean, like if you go left to right of the point, the curvature will just swap, like it will change from convex to concave or vice versa. So that's very interesting point. It is also called the saddle point in advanced mathematics. So this is also called saddle point. Saddle has come from the word, like I hope you have seen the saddle on a horse. So we have a, you know, if you try to go for a horse ride, so what they put across the body of the horse is called saddle. The jockey will, I mean, sit on the saddle. This is very interesting curvature. It's a two-way curvature, this way and this way. Like, difficult for me to draw. And like any, if you look at any wafer from Lay's, so that is a very close approximation to the saddle point. Like the shape is really interesting. Have you seen the chips or the wafers? So next time when you eat a wafer, try to look at the shape. It's really interesting. It is curved in two ways. Have you seen that? No. No one has seen? Hello, 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 hello.
Sir, we have seen.
Okay, you can reply. You guys can reply. When I'm asking something, you must reply. Okay, all right. So now that today we are going to discuss more of the problem. So let's start doing some problems. The problems which really fascinate us. So we'll start with a very famous quadratic expression. So if y is written as ax square plus bx plus c, this is called a quadratic expression, and this expression can have a graph like this. So there are various types of graph possible in case of quadratic function. So you may get graph like this, like this, like this. There are three possibilities. You may get a graph like this, or like this. So the three possibilities here, three possibilities there. The first three possibility is for A positive, the last three is the A negative. Okay. The topmost graph, like if I name it like 1, 2, 3, if I say this is 1, this is 2, this is 3, in fact, I should just change the number. Right? I'll say 2, this is 1, 2, 3. Now, what is 1? 1 means there are no real roots because the graph is not touching the x-axis, so there is no roots, but still you will have the minima you can see. So in the first graph we have minima at different points. In second we have maxima you can see. So how we can find these values using the concept of calculus? So y depends on x. So for maxima or minima, the first derivative must be 0, right? And if you differentiate, what you get?
Sir, but in the first case, the one which is not touching the x-axis, there will be no zeros. So how?
There will be no solution, but graph will have the minima. Na? Like, so what is the meaning of this? We are not solving quadratic equation. We are not solving it. When you solve a quadratic equation, you get some roots, right?
Yes.
So the root means the meaning of root. If you try to understand graphically, it means how many points the graph is cutting the x-axis. That's for roots.
Yes, sir.
So if a graph is not cutting at all, we say there are no roots. If graph is touching at one point, we say identical roots. And if the graph is cutting at two distinct points, we say distinct roots. Can you see that now? So we are not solving. We are not solving quadratic to get the answer of roots. We are trying to find the location at which the graph attains the local minima. That's it. So for maxima or minima, the first derivative must be 0, which will give you x equals to minus b by 2. Okay. So minus b by 2 is a very famous relation. It always gives you either a maxima or minima, depends on whether it's a like
So it gives the
a.
minima of the graph.
It may give maxima also.
So the maxima for matlab, means the highest point is always.
Sir, it gives both maximum and minimum, but it depends upon value of a.
Yes, sir. It depends upon the type of
Correct.
a. If a is
Value of
greater
a.
than 0, then it
Correct.
will give maxima, and if a is smaller than 0, it.
Sir, but I have one doubt. Sir, why did you equate dy by dx to 0?
Yeah. So because we are trying to find the location at which slope is 0,
Okay, sir.
right? So now let's differentiate once more. Like this is okay. The first derivative we
Sir,
got is
sir, sir,
2.
sir, will you repeat what you just said?
I said that when you equate dy by dx to 0, it's a way of saying that you're looking for the points at which the slope is 0, because dy
Yes,
by
sir.
dx represents slope. Now we
So,
have,
sir, minus
yeah,
b
tell
upon
me.
2a is the points for maximum minima, which indicates the slope for 0.
This is the critical point at which you will have a 0 slope. That's it. But whether it will be maximum minima is still one step away. So we have the first derivative here. Not differentiate again. So we got 2a. Okay. So now we can see that the second derivative will be positive or negative. It entirely depends on a only. So b and c never decide what will happen. Okay. So a alone gives the idea whether it's concave up or concave down. If a is positive, so double dash is also positive, which means what will get minima. And if a is negative, then the double derivative will be also negative. And so what will get maxima. What does it mean is the a positive means it is concave up. So what you can get is only minima. You can't get maxima at all. And if a is negative, it's concave down. So what you will get is maxima. And it is also proved by the mathematical derivation. So A of quadratic, decides everything. So if I give you any expression of quadratic, you can easily plot the graph. At least quickly you can plot. This is done.
Yes, sir. Done.
So this is the first expression. We'll go to the next. So if I give you equation like y equals to ax minus bx square, where a and b are positive. By looking at the expression, can you tell me, are we going to get a maxima or minima? What we are going to get here? This is the quadratic equation, right?
Yes, sir.
I mean, I won't say equation, it's a quadratic expression. So the question is, this expression will have, we have shape of concave up or shape of concave down. What do you think?
So concave down.
That's right. Right. And why it is down?
Sir, because
Because
x
a-
square coefficient is negative minus b.
Exactly. Because the x
And
square,
thus it is less than 0. So
yeah, so the x
Ah,
square
yes, sir.
coefficient is negative and it's concave down. So are we going to get the maxima in this case or minima?
yes, sir.
So what we will get, maxima or minima?
Sir,
That's the question.
maxima. Maxima.
Exactly. So can you tell me the location of maxima? So where will we get the maxima? At which location? The other way of saying is, where is the critical point?
Sir, a upon 2b.
Correct. So it's a upon 2b is the right answer.
So
So here, so for critical point, you cannot directly connect in the way, if you remember the answer, that's very easy. So for critical point, either you could have said minus b by 2 a formula, but here b and a are reversed. So minus b is here a and a is minus b. Right? If you compare, which is a by 2b. But let's say if you don't remember this, so you can say y dash equals to 0, which will give you a minus 2bx equals to 0. This will give you x equals to.
So this
This
will
is
be
your
local maxima, no?
sir, this
yeah
point of
yeah
x will give maximum on x-axis or only.
yeah. So this is the critical point at which you will have the maximum. Now here we have just only one maximum, so that's a local and that's global as well, because you won't get the other maximum. So in a quadratic equation, we can get a maximum only one value. So you can't get the two values of maximum or minimum like that. Now the if you plot the graph, how the graph will look like? So to plot the graph is very
So
easy.
it will downward parabola.
Correct. If I put x equals to 0, the y is how much? If I put x equals to 0, y should be
Sir, 0 only.
a. Correct. So the
Origin.
graph will, the graph will be beginning from the origin. It will go up, will become maximum, will go down, and will continue this way. And I can continue this way also. So mathematically, this is the graph, and the answer which you got is this value. Can you find the maximum height? This height I'm looking for this height, the h max. What is the h max here? So it is f of a by 2b, right?
Yes.
Yes, sir.
And
Yes, sir.
what is so you can see that fx is what? What is fx here? Fx is ax minus bx square. So can you find the f of a by 2b? You can find a by 2b minus b a by 2b whole square. Can you write like this? So a square by 2b minus a square by 4b. And if you subtract, you get a square by. So this is called the maximum value. This is the
So this
point
is the
at which,
height.
yeah, this is the height, the maximum value, the y max.
And if we want to calculate the
X
distance between
component.
the maximum point to the y-axis, then
So that is the distance here, a by 2.
Sir, X only.
yes, sir.
Yeah, that's x only. Correct.
So,
Yes.
sir, I understood till x is equal to a by 2b wala critical point. Then after that, what did you do to get the graph?
Okay. The graph is like it's a downward parabola. Okay, because the coefficient of x square is negative. So every quadratic equation will have a shape of downward parabola or upward parabola depending on the sign of coefficient of x square. Because here the coefficient of x square is negative, so it's downward parabola. And if you substitute x equals to 0, it will give you y equals to 0, which means the graph will pass through origin.
Sir, this x is equal to a by 2b is the point on x-axis
Yeah,
which
correct,
has
correct,
the maximum
correct, correct,
height.
correct. Yes. So x equals to a by 2 is the point on the x-axis at which the y becomes maximum. So if you walk along the x-axis and if you look at the graph above you, then the highest point of the graph will appear at x equals to a by 2b.
It is the critical point of maxima, right?
Yeah, correct. Critical point always gives you either maxima or minima. So we are getting here maximum. There should not be any doubt here. That's very simple. And regarding to the plotting of the graph, it's a downward parabola which is known to us. So what we do next is we just take some values of x where we expect it should pass. So we always check for the origin, whether it is passing through the origin, above the origin, or below the origin. This is what we always calculate. And how we do it? We put x equals to 0 to see the y value. So if you substitute y x equals to 0, the y will give you 0, which means it is passing through origin. Okay. Imagine if I write like this, y equals to ax. Okay, let me give you some value, something interesting to solve. Y equals to, let's say, 4x minus 10x square plus 2. Now, if I put if I put x equals to 0, what will get y? At x equals to 0, y is how much?
2.
Correct. Y is 2. So one thing is sure that when x is 0, y is 2. So graph will, when it is 0, graph will cut the 2 value. So it's something like this. And why downward? Because we know that it's negative, so downward parabola. Now the question is, sir, where will get the maxima? You will get the maxima again at the same point. Where? X equals to. Can you tell me the maximum value? Location?
So 1 by 4.
Yeah, so you can differentiate. You will get 4 minus 20x is 0. So x equals to 4 by 20, which is 1 by 5. So definitely at x equals to 1 by 5, you will get the maximum. Can you tell me what is the maximum value of y? What is y max? Can you tell me y max? Y max is how much?
Sir, f of
25
1
by
by
4. 25 by 4.
1 by 5. Yeah.
1 by
So what we're getting is 4 by 5 minus 2 by 5 plus 2, which is 2 by 5 plus 2, which is 2.4. So the maximum value of y is 2.4. So that's easy, isn't it?
Sir, so what is that a upon 2b?
Pardon?
Sir, I put the value a square upon 4b. So I
We have
got
put
25 by 4.
25 by 4. Why you have put a square by 4?
Sir,
Because the
because
equation, because,
I
but the equation is not same. No? This is different. This is different.
so I took minus 10 square upon 16.
No, no, no.
Sir,
Don't
it
use
is
the.
wrong. So,
Yeah. You have to derive it again. For every question, you have to derive from basic. Because this is here the constant is missing. There is nothing called written here plus 2, 3. But if we have written here plus 2 here, so that's a different thing. So if you start from again basic, differentiate, get the roots, the critical points, substitute to get the maximum. Not clear?
Yes, sir.
So can you explain once again?
Which part? Tell me.
So after differentiating that,
Yeah. So when you differentiate, you equal to zero. You differentiate and equal to zero because you want to see the
yeah, sir.
zero slope. You are looking for zero slope, right? You're looking for zero slope. So you differentiate means you find the slope. You equal to zero means you're trying to look for the zero slope. And if you solve, you get this answer, which means at x equals to 1 over 5, the tangent to the graph is 0. Like this. That's it. So here the slope is 0, no?
Yeah, sir.
So this
And
is
then
what
at
we did.
x is equal to 1 by 5, it will be the maxima.
Correct. So if you substitute that value in the actual expression, the y expression, you'll get the maximum value of y. Okay?
So this is the local maxima, right?
Yeah, this is the local maximum.
Sir, we actually cannot we cannot actually find the high high maxima of the whole equation, right?
No, in this case we can say, because in this case our graph will only go downward. So there is nothing going beyond this, right?
So I
So
have a
nothing
doubt.
is, yeah,
So when do we do double differentiation then?
we always do
So when?
to find the to compare whether it is maxima or minima, like to separate the two distinction,
Oh,
whether
ha,
it
sir.
is,
Ha. If that.
okay. So anyone, any doubt? Shall I move next?
Sir, I have to copy something.
So yes,
No.
I have a doubt.
Go ahead, go ahead.
Sir,
Yes.
sir, at the end of the lecture, can you explain in short that partial differentiation, one sum of partial differentiation?
All right. You can do it. You can. Just remind me at the end of class. Okay. Not an issue. You can do it. Just remind me. All right. Okay, guys. So we should go to the next problem because this is taking too much time. So let's
Done, sir.
do one more problem. Okay. Practice till you get the hang of it. It may take some time. Don't worry about it. Everyone start from zero. Like even when I started, I was having same kind of confusion the way you guys are having. So nothing wrong in it. Okay. You should have confusion. You should must clarify till you get the hang of it. So let's do still. I mean, we are not giving up. Let's solve this question. So 3x minus maybe okay. No, that's all. Now, can you see this expression now? Plus 5. So can you find big C? It's a quadratic equation, so you will get only one critical point. You won't get much. Because if a expression is quadratic, so the differentiation will give you linear equation. So when you differentiate a function, you get an expression less than 1 in terms of power. So we have quadratic differentiation gives linear. If you differentiate linear, you will get constant. If you differentiate constant, you will get nothing. That is 0. So we have a quadratic to begin with. If I differentiate it, what will we get? What we're going to get here?
Sir, 3 minus 4x is equal to 0.
Correct. So, correct. So we can write as f dash x. This is the way of writing. You can write f dash x equals to 3 minus 4x. Now double differentiate once again. What will get?
Minus
Minus
4.
Minus 4.
Now, because it's a fixed value, it's a negative value, so you are only going to get the maxima without any further check. So whatever be the critical point, the answer will be only maxima. So now to find the critical point, what we do? We equate to 0. So we get x equals to 3 by 4.
3 by 4.
So now what is the y max? The y maximum will be how much? It's f dash 3, sorry, not f dash. F of 3 by 4, right? Just
Sir, it is 9 by. Sir, it is 9 by 8. Hello, sir. Hello, sir. Hello, sir. Hello, sir.
Sir, it's 0.9.
It is 9 by 8. Hello, sir.
okay. So you got the answer?
So 94 by 16.
1.1.
So f of 3 by 4 turns out to be 9 by 4 minus 9 by 16, 9 by 8 plus 5, which is 5 plus 9 by 8, which is 49 by 8. Is this the answer?
Sir, I did saw plus 5 actually. Yes.
Pardon?
So, yeah, 49 by 8.
Yeah, so if you have missed the 5, then of course your answer will not be right. So don't try to miss the expression. Expression we have to follow always.
Sir, no,
I
sir.
got 47
It
by
was not visible for me for twice. I copied wrong question.
Sir, I got 47 by.
Why? How can you get 47?
So my answer is 6.125.
Yeah, that's correct. That's correct. If you have divided, that's 6.125 is the right answer. And
I
that's
used
correct.
calculation mistake.
Yeah, so maybe some calculation mistake is always there. Yeah.
So I had a question. So we did f double dash of x and we found it to be -4, which is less than 0. We did that just to check, no, see if it is maximum or minimum.
Very true. That's correct. That's the mathematical way of checking. So we have also, if you can see the actual graph, if you know how to plot a graph, then even those checks are not required. But when we have a doubt, when we are not able to visualize the graph, then definitely one should go for mathematical check. So with experience, you will also realize that, okay, not every time you need to check. You can just do away with the second derivative part. You can just stick to the first derivative part. And in 99% case in physics, that answers the question. Okay. So anyway, so let's see some more problem. So I'll just give you some more realistic problem. Let's say it's called the multiplication problem. That's very interesting. Multiplication problem.
So is this a just problem or a new concept?
No, just problem. That's numericals. We are solving question based on the concept. So imagine if I have two numbers x and y, and if the two numbers when you multiply, when you add, it gives you 100. So you have not 100. That's too much. Let's say 10. That's it. So let's say you have two numbers x and y, which when you add, it gives 10. So what are the possible values of x and y? Can you guess the values of x and y?
Yes, sir. 10.
No, x and y.
That's 10 and 0, 5,
10 and
5,
0.
Sir, it can be
8,
infinite
2,
also.
2,
Sir,
8.
it can be infinity.
Correct. So they are
So
infinite
yes.
combination, right? So the question is, I'm defining a new quantity called z, which is the product of this x and y. The question is, for what value of x and y the z will be maximum? So
So
Find-
it will.
to maximize z.
So 5 and 5.
That's right. That's right answer. So how we can solve? How we can prove it by mathematics?
Y equals 10 minus x.
Yes, we can write z equals to x into 10 minus x, which is like a quadratic equation that we have earlier, just like the old question, right? See, so we have converted a problem from the multiplication problem to a simple quadratic formula, and we know the answer even in advance. So even if you do the differentiation, because you want to maximize z, so now z is a new quantity you want to maximize, so you will differentiate with x. You get x minus 2, and if you equal to 0, you get and we know it will give you maximum only, so no need to check further. And therefore the answer is 5 and 5. So it's a very, something very interesting that you should remember, that if the sum of two numbers is constant, the product will be maximum when numbers are equal. That's how we say it. What we say? If
Can you repeat?
the sum of two numbers is constant, then their product will be maximum if the numbers are equal. I'll just put it here. Don't worry.
Sir, if we are using derivative in any of the problems, like if it contains quadratic equation, and if we differentiate the values, and then we have to forcefully equate it by 0.
No, not forcefully. See, what you're trying to find is, okay, you're not realizing every expression is having some geometrical shape, and you're trying to locate the points on the geometry, on the graph, at which the slope is 0. So slope is 0 in mathematical way is called dy by dx equals to 0. It's the same thing.
Yes, sir, crest or
Correct. So dy by dx is the slope, no? What is the geometrical meaning of dy by dx? If you
sir,
remember,
but x square, sir, the quadratic equation always gives the value equals to 0 when
no.
it is on the x-axis, right?
No, nothing like that. The quadratic never gives 0. Quadratic is quadratic. It never gives you 0. When you equate to 0, you're trying to find the value of x where the expression becomes 0. That's called the equation, the roots of the equation, the zeros of the equation. Okay, the more you learn mathematics, you'll understand. So right now you're confused.
So you told in the last, if we are equating to 0, then we are saying that the slopes on having the
Correct.
slopes on 0.
Correct.
So this is only applicable for quadratic equations.
What? No. We can solve for any question. So why we are solving quadratic? Because the kind of question that you will come across will be mostly quadratic. It can be cubic also. It can be anything. There is no restriction on that. Let's do some more advanced questions.
So when numbers are equal, meaning
When numbers are equal, it means x and y are same.
oh,
You can say x equals to x, y I mean, you can write it 2x equals to 10, so x equals to 5.
Sir, but this is not given to us.
This is
Not given to us, no. That
yeah.
x
This
is
is
equal to y.
no. It's not given. You have to differentiate and derive, or else you can remember the answer like this way.
If it is the condition that x is not equal to y, then there are two different possible, that x is equal to 6 or 4 and y is also equal to 6 or 4.
And they are infinite. They are infinite possibility.
Sir, how? Means if the maximum value for z, no. So
So
then
maximum is only possible for only one particular value. There is no other value for which you will get the maximum. Maximum is always only unique in quadratic, right? In quadratic, you can get only one crest. Can you get two crests?
sir, but
Can you
in quadratic we also get two different values of x, no.
Okay, so you have studied quadratic, right? I hope you have learned about quadratic. What is quadratic equation? You write ax
Which has zeros to
plus bx plus c. This is the quadratic expression. Okay, this is the quadratic expression, and you equate to 0. Okay, so this is what you do. This is called quadratic equation. Now, what is the equation? What do you mean by equation?
Sir, when there are two values equate
No.
with each other.
Very bad theory about this. What is equation? Have you learned equation in class 10, 9, whatever class? There are two things in mathematics, in algebra. One is called the expression, which is just the way you write anything. Other is called equation. And the equation means you need to understand why you write an equation. Equation means you are interested in knowing that where the expression for what values of x value, like what value of x I should put in the expression, which can make it 0. So don't think about this. Just forget about this. I am just giving you, let's say I'm giving you a random expression. I'm giving you 2x squared plus 5x minus 4. I'm not saying it's anything. Just think of this expression. Let's say you have no idea about, just this expression. Just a moment. Sorry, guys. So now this is the expression. Don't think of anything. Before what you have learned. Okay. Now tell me, if I just ask you a question, that can you tell me what I can replace x with, so that the calculation gives me 0? That's my question. Can you say me how to do this? Don't solve it.
calculation.
I'm saying that can you guess the number which if I put instead of x, the expression turns out to be 0. So you get confused. Okay, what is this question? Let's say I'm asking a different question. What I must substitute x, which makes the entire expression 1? What I must substitute x, which converts this entire expression into a number 10? That is called equation. When you equate something to 0, it is a way of saying that can we really find some x which make the entire expression 0? I could have put 5 here. Then the question will change. Can you find the x which can make it 5? I can put 10. Can you find the value of x which can make it 10?
Yes, sir.
That is the meaning of expression. So there is no answer. See, when you say two answer, there is nothing called two answer. That is a question actually. Can we find some, can we guess the value? When you say this is 0, it is like a saying the same thing. Can we find the value of x which can make the expression 0? Then it turns out that we have a given some ready-made formula to a student that you can do it. So what you do is you use a formula minus b plus minus under root of b square minus 4ac upon 2a. Now using this expression you get the answer, and this is what we derive in class 10th, right? If you know the derivation of this, have you seen the derivation of this?
Yes, sir. Today, yesterday only, sir, taught us.
Yeah, so it is x plus b by 2 a whole square equals to b square minus 4ac upon 2 upon, of course, 4a square. So this is the answer which you, if you had deriving this. Now why we derive this way? Because the obvious thing is we cannot solve for x if it is not linear. We only know how to solve linear equation, right? If I say what is, let's say I'm asking 2x minus 2a. Now tell me guys, what I should put here x value so that it becomes 0 without solving.
Sir, 1.
Now this is, you are able to say it because it's simple, it's a linear equation, right? Now as the equation becomes complex, we cannot see this clearly. We don't have a way to see it, so we have a formula to solve. So we know that this formula will eventually give the guess value. The value you are not supposed to guess, rather you're supposed to use the formula. Okay, so which is derived using some sort of manipulation, converting into linear equation. Everything we solve only in terms of linear equations. See, remember one thing in your life: we can only solve linear equation. That's it. The rest we have to convert into linear and then solve. Now, what is quadratic? You know what is quadratic?
Sir, yes.
No, you don't know what is quadratic. What is quadratic? Tell me.
So quadratic is the equation which has two zeros, two roots.
No,
Two different roots.
quadratic is the equation.
Quadratic equation is an equation which denotes or is responses to the graph of some line which is type of parabola and which crosses the x-axis twice. Is nothing but, or is possibly crosses the x-axis twice, for which y values to be 0 and x values to be something which is
Okay, understood. Okay, so you have said everything, whatever you have seen so far, but the quadratic equation is, what he said is correct. It's like an expression which can maximum have two roots. You cannot say it will have two roots. That's wrong to say. The maximum it can have is two roots. It can have be 2. It can be 0.
1, 2.
It can be no roots also. It can be just one root repeating. So the maximum value of root is 2. It can be less than that also. Okay. So imagine if I say something like this. Let's say I'm telling you that x minus a1 multiply x minus 2 equal to 0. So it can have two answers. Either this is 0 or this is 0. So you can have 1 and 2 as the answer. Now this picture, if I really multiply the terms, what I'll get is x square minus 3x plus 2. Now this is quadratic. It means a quadratic equation can be factored into two linear equations. That's the idea. And every linear equation will have one answer. So this can have maximum of two answers. What if we fail to convert into linear equation? Yeah, if you fail to convert, it means you cannot get any answer in you cannot get the linear equation, and so you cannot get any answer. Let's say if I'm giving you x square plus 4 equals to 0, you can't solve this. You can't convert it into linear equation. So we say there is no solution. This is also quadratic. But if you learn advanced mathematics,
2i.
yeah, you can say it's a complex number. You can say this you can write as x square minus 4i square. Now this is like we can write x minus 4i and x plus 2i and x minus like this equals 0. So we have some complex roots. We can say plus minus 2i. Now that's we only look for the real solution. We are not interested in going for the the virtual, or you can say hypothetical or complex solutions. Okay, but the idea is, then why we learn? If we cannot solve it, then why we learn? The idea is, although it cannot have zero, it does not mean it does not exist. Just because if I draw a graph like this, can we say it does not exist? Graph is still real, isn't it? So let's say this is a river. Okay, a person is driving his bike towards the river, and then he suddenly realizes that it's a river, so he will make a sharp turn and will prevent himself from getting into the river. So let's say he does this stunt. Now my question is, although if I choose if the person is not going into the river, does it mean that this path is incorrect? Does it mean the person does not exist?
No, sir. Sir, it
Everything is
exists,
real.
but it has no zeros.
It means the graph is real. It is not meeting the x-axis, and that's not a bad thing. If the graph is not touching the x-axis, there's nothing wrong with the mathematics. So if you ask that, do we have solution? Do we have the value of x at which okay, is it possible to have y is 0? The answer is no. Y cannot be 0. Here y is not 0, but not being 0 is not a bad thing. Come on, not being 0 means not being 0. That's it. So when you are equating the equation to 0, you are asking a question: can we have a values of x which can make the expression 0? The answer is no. You can't have. You can't have the value of x which can make it 0. So don't get upset by this fact. Oh, we don't have x which can make it 0, so it's a bad thing. It's unreal. No, no. It means there is no value of x which can make it 0, but the graph is still something real. Okay. So that is why we still learn the concept of complex number. So that's very interesting part. So the quadratic, you equate to 0 to get the answers. Okay. It does not mean that there are two roots and that and that and that. Okay. So I hope you have got the idea what I'm trying to say.
Yes.
And
Sir.
what we are learning and what you're trying to say. I mean, the confusion should have been gone. Okay. If not, then okay, think more about it. Try to contemplate on your own. Hopefully, you will come across. come with some new ideas, which will be
Sir, it
presented.
depends upon us what we equate to.
Correct. So this is like a question, asking question to someone that can we have the value of x which can make it 0? The answer is no. You can't have a value of x which can make it 0. That's perfectly okay. That's perfectly okay. What a big deal. Okay. So it is like you're trying to go to your school, and on its way, your friend is also there. But your friend home is, of course, off the road, off the highway. So if you want to meet your friend, you have to go all the way to your friend's home. But you decide to go on the highway itself, so you never meet your friend. That's it. So the graph is moving this way, trying to come closer to the x-axis, but not touching the x-axis and going again away from the x-axis. And therefore, we can say that it will never meet the x-axis. So y cannot have 0, but y can have this value, right? This is the value. Let's say this is 5. So I can say the y can have the minimum of 5. Y cannot go below 5, right? So what is the minimum of y? The answer is 5. What is the maximum of 5? Oh, we don't know. So what is the maximum of y? It's infinity. Isn't it?
Yes, sir.
So that is the idea. Maxima, minima only talks about how below, how low you can go, how above you can go. That's it. It never says that whether you are cutting the x-axis or not. That's why we are getting the answer. I hope this makes now some sense to you guys. Okay. All right. So, okay, this was a very good confusion. I think I would say it was a great learning for you guys, and the quadratic meaning is now. I hope this meaning is clear to you guys. So don't learn mathematics as some formula. Try to see the meaning of it.
Sir, I was saying I got disconnected. Sir, before that, I was saying that, sir, if x and y are given that they are not equal, then the highest maximum value could be 6 and 4, no?
Correct. The highest maximum value.
Sir, but how there will be two values if
No. That's what he's saying is wrong. So what he's saying is that if x plus y is 10, So you have to maximize the product. So you are saying 4 and 6, right?
Yes, sir.
6 4 is only to 24.
Yes, sir. So, sir, if x is not equal to y, I'm saying that.
So let's say I'm taking this one.
So then there are infinitely many solutions.
Correct. So let's say I'm taking this value. Can you multiply and tell me the answer? Harshit, I think you can tell me the answer. Using calculator. You can use
24.75.
Okay, fine. Okay, now do this. 4.5, 4.6 into 5.4.
24.84.
Just have it cross the value. Just 4 this is 4.4. Sorry, my bad. So 4.6 and how much we have to add to make it 5.4? Right? Yeah. The sum is 10. Yeah, that's correct. So how much this is giving you?
24.84.
What you can see that if you try to move closer to the value of 5, if I make it 4.9 into 5.1, now tell me the value.
24.99.
Correct. If I tell you 4.999 into 5.001.
24.99999.
Correct. So that's the idea. The idea is simple. The idea is that unless you will not become exactly 5, you will never achieve the maximum. So maximum is only when both are 5.
Sir, but if you multiply 4.999 into 5.111, then answer is coming 25.555.
So but addition will be maximum, no? Over
But
10.
you have exceeded the some value, isn't it? You know addition? Add these two numbers. Tell me, is it more than 10 or equals to 10?
More than that.
But the condition is, so you cannot take this number, isn't it? Right?
Sir, 4.99 into 5.1.
So even if that is more than 10, no?
No, sir. 4.9 plus 5.1 is 10.
4.9 only. 4.9 into 5.1, right? What you are saying, you're not saying correctly then.
Sir, you wrote it up. 4.98 is 5.
So that is the 4. This is not. This is less than 25. Either you're doing the calculation mistake. Tell me. I hope your confusion is gone. Else, just check your
Yes,
calculation.
sir.
Yeah. Okay, so the idea is simple. Okay, the idea is okay. The calculus is a way to arrive at the maxima or minima. That is why we say optimization problem. I'll just give you some more, geometrical examples. Let's say we have a river. Imagine this is a question. We have a river, and you want to create a fence for your cattle and all. So we want to create a fence. So you go and buy the fencing wire, and you are supposed to fence only from the 3 sides. The other side is like some sort of ocean, beach, or maybe some river, some pond. So you want the other side to be open so that the cattle can go and have the water. So let's say this is a pond. Now you want to fence this part only. And when you fence, you create some area, right? Now what I give you, I am giving you the L is the length of fencing wire. Length of fencing wire. So with the same length, you can create a like this fencing. You can create a fencing like this also. You may create a fencing like this. So the idea is which shape of fencing, like what dimension of the rectangle will make the area greatest. Okay. So question is, I want to maximize the area. So how I must choose this length and this length?
So equal length. Which
The idea is that
X
total
and
length is
X.
L.
So
So first
one
of all,
should be X
how to start
and
with?
second should be L minus X.
So the first is you are saying wrong. What is the perimeter of the rope? What is L equals to?
4 into 2 into L.
It is rectangle.
It's not rectangle. It's a fencing only from three sides. No? The other side is not there.
So 2X
So
plus
L is 2x plus y only. This is the first condition. Now I can say y is how much? L minus 2x. That's fine. What is the area?
A.
Oh,
X,
sir,
Y.
it will be X into Y. Yeah.
X, Y.
So now we have converted into a simple equation of x only. So a is a function of x. A is a function of x, and you want to maximize a. So for a max, the first derivative must be 0 first of all. A is a function of x, so I want to maximize
Yes,
the a.
sir.
So it must be 0. So if I differentiate and equal to 0, what will we get? What we are going to do? Tell me.
L plus 4X. Sir, L is constant. No? So L plus 4X.
Just a minute. Okay. Okay, so the area is it's a function of x, so we can always differentiate. We know when we have function, we can differentiate. So can you guys tell me what is the differentiation value?
Sir, L minus 4X.
So let me just check what you said is correct. L minus 4x is the right answer. If I go to 0, oh, so I got the answer of x.
L by
That's
4.
very nice. And y is how much then? L by 2. Right?
Yes, sir.
Now see the beauty of calculus. You want to make a fencing, okay, and this is not only restricted to the same. You can imagine that if I want to create a room with the least number of bricks, okay, so you want to maximize the, you want to cover the room with maximum area, and you want to create a least number of bricks which can be used. So let's say you want to cover an area of 100 meters square. So mathematics will tell you quickly that you must create a square room. So now if you look at the construction, most of the building construction, they always try to create the square room, square kitchen. So those who create the square room or square kitchen, why they do so? Because they use the concept of calculus, and calculus says that you can cover the maximum area with the least fencing of wall. So these are something very realistic thing. I'm giving you the very fundamental example of application of calculus, but it can go to very complex, situation as well. Yes, tell me.
Sir,
Sir,
if
can you
X is
explain
equal to
this?
100 meters square, so what was the second condition?
So if you want to create a 100-meter square room, so just take a 10 by 10 room. Take the square room. So the base of the room should be square.
Okay.
Sir, sorry, sir, I was not able to hear you.
Says 10 and 10.
Yeah. So you want to create a room of area 100 meters square, just to make a 10 by 10 room. That's it. You make a 10 by 10. You could take a width 10, length 10. That's it. and then
Yes, sir.
you make your but you could have created like 20 to 5 also, right?
Yes, sir.
But 20 to 5 will actually occupy the area same, but it will take more bricks, you know.
25
It
by
will take,
4 also.
yeah, 25 by 4, it will take even more actually. That's very interesting that how things can be, you know, designed, which can have a consequence on pricing. So the cost effectiveness is very much, I mean, measured when you create a launch a product. So if a company is trying to make a, let's say, Pepsi can, the can in which the soft drinks are filled. So the shape which they design and the shape which they choose, the can is made of a tin. So to minimize the material which can, you know, contain the volume which you're looking for, let's say you want to have a 250 ml of can. So the volume is a fixed quantity. Volume is something which we have the kind of constraint. And now you want to design something which can keep that 25 ml, 250 ml in the least possible material. So how much is the least possible material I should use so that I can keep that? Okay. So
The
these
volume
things,
of least possible material or area.
So what
area.
is the
If the area is least, then
shape?
material is least. Yeah. So we can do this problem. Let's do this.
So
So
what
let's
is the
try to
shape?
create
What?
it. Yeah, tell me. Yes, yes. Go ahead.
Sir, I was saying that if volume is 250 ml, sir, but what is the shape cylinder?
Yeah,
Or
I'm taking the cylindrical. Yeah, I'm taking the cylindrical can. Can is cylindrical. Okay, so let's try to design the can for a company called Pepsi, which can be cost effective to the company. So you are the product manager, and your job is to save money for the company. So you will use simple calculus, and you can do the magic. So as you go further, this will take a shape of some complex mathematics called differential equation. And in industrial scale, the optimization problem takes maybe more than 10 variables, 20 variables, and it's done with the help of some computer software. It's not done mathematically or manually. So we have advanced mathematics for the same. And people, those who do the research in PhD in mathematics, they do those things called optimization. So it's a really interesting field. Okay, so let's say I'm trying to design a can. So my job is to design a can. The can comes in the shape of, imagine, like a sheet. Okay, so you have the sheet. That's it. Okay. So what I'll give you a sheet of area A, and area is constant. Let's say this is given to you. So I give you a piece of sheet. You can cut into as many pieces as you wish. I have no problem. And you can imagine that, okay, every piece can be joined into a given shape, so there is no wastage. Let's say there is no cutting and wastage. So this is what we assume. And let's say the can is closed can. This is a closed can, so it's closed from top, it's closed from bottom, and it's closed from sides. That's the idea. Now, how we start solving a question like this, how we formulate the question, so what our desire is, what our goal is, that how to maximize the volume. So V is something that we can always think of. So you can create a flat can with a bigger base and a small height. It may have some other volume V dash. So I want to take the measurement of the height of the can and the radius as X, two variables, and I want to maximize the volume. So first of all, I will write the area of the can. What is the area of the can? Two flat surfaces, pi x square into 2, the top and bottom
Pi r
area.
into r plus h.
And then we have the third curved surface area, which is 2 pi r h. Now this is the constraint. This is the something which is given to you. So you can choose x and y, which can have this formula. Okay, that's very interesting. I can write y from here. What is the y? 2 pi xy equals to a minus 2 pi x square, and therefore y equals to a minus 2 pi x square upon 2 pi x. Oh, that's nice. So we got y as a function of x. Now comes the volume part. What is volume? If you don't know, the volume is how much? Pi r square h. Yeah, that's nice. Pi r square and h. Okay, we got the value of x. That's very interesting. We have the answer. A minus 2 pi x square upon 2 pi x. That's it. Now this is something very interesting. X will cancel out in fact, and what we are getting v equals to is ax by 2 minus 2 pi x cube. Oh, that's nice. That's good. So we have a very beautiful relation of volume and x, and this expression is something which we have to now use to maximize. So now we know how to maximize something. So v is a function of x. So how to maximize it? You will say dv by dx equals to 0, because you want to find the slope of this graph where it's 0. So if you differentiate and equal to 0, what will get? A by 2 minus this will cancel out in fact.
The 2 cancel.
Yeah, so 3 pi x square nevertheless is 0. So I get x equals to a by 6 pi, and that's nice. See, if you give me a material, the length, the area of the sheet, I can tell you what x and what y I should choose, which can occupy the maximum volume.
In this, sir, in this volume only we can find the maximum, the dimensions of.
No, we can find the dimension which can maximize the volume. So the height ratio, the radius, the height and radius must be in certain proportion, which can maximize the volume, keeping the amount of cost least. And cost will be proportional to the area of the can, isn't it?
Yes, sir, that only, sir.
Correct. So now if you want to create you have a gift company, you want to create a gift wrap. Okay, so what you will suggest to your customer that you must take these boxes to use for gift, because the box will have the least area, and so it will take the least wrapping paper. So the idea is, the concept of calculus, although we are learning the very basic, the very fundamental one, but this can be exploited to solve even the one of the trickiest problem of a real life scenario, and that is what exactly is done in real life. So maxima and minima, it's a beautiful thing, and that is the power of calculus. You can imagine that calculus is so powerful that it can solve various problems. Okay, in fact, the stock market works on maxima and minima. It also works. So we have there are various things, like I can keep on going about the maxima and minima. So let's see some more problems. Okay.
Sir, but
Yes.
sir, can you show the previous one?
Yeah, I have saved.
So what did you write in under root a upon?
6 pi. See, I will tell you how to start thinking.
But where is the 3 in the
Pardon?
equation? So where is 3 in the equation? So, but there is no 3 in the volume is equal to ax plus 2 minus 2 pi x cube. You differentiated it somehow.
Yeah. Okay. So what I'm trying to say is, okay, I mean, the way to start thinking, let's say for me, it's very easy. I can do it very quickly. But for a beginner, it's very difficult that how shall you start thinking? So the rule is called the constraint. First, identify what is your constraint, what is your limitation. So as I said, here the area is the limitation to me. All right. Now choose the dimension as you wish. So I choose x and y. You can choose anything. You can say u, v, w, x, y, whatever. Then write the constraint in terms of variable, which I did here. You can see. So I have written the constraint in terms of variable. Now convert the one variable into other. So I have written y as a function of x. So now I can express y as x. So I will have only one variable because I want to deal with just one. Now what I want to maximize. So write the name of the variable you want to maximize. You can say volume. You can say whatever. So I'm
So
writing
you
v.
gave it 250 ml, no? Sir, if you gave 250 ml, so what will be the answer?
Yeah. So now I see I have the formula. Let's say I have the v formula for the maximum case. Now I will put v 250 and I will find a, the other way around. Okay. So let's say I got x, and then what is the maximum volume? So v max is how much?
Sir, for x what?
X this is the x. So now we can find the V max, which is A by 2 into X. X is under root minus pi X cube. Yeah, X cube is how much? So it's A by 6 pi. A by 6 pi. That's very interesting. The root will be like this. So what you can take common? 5 will cancel out. You get A by 2, not A by 2 common. You can get A common. So that's too much hodgepodge. Maybe you are getting confused because of this. So yeah, I can write this 1 by 3. So 1 by 2 minus 1 by 6 is 1 by 3, right? 1 by 3 is A by 2, A by 6 pi. So I can write this as A cube upon 9654. This is the answer. Now I got the V max formula, the maximum volume in terms of area. Now you can put V max as 250 and you can find area.
Yes, sir.
So now you can put 250 ml as a 250 centimeter cube, and then you can solve and you can get the area. That's easy. So you'll get a centimeter square. So I in fact I can do it right away. 250 square equals to A cube.
Sir, in which equation did you put x is equal?
Yeah.
Okay.
So in fact I can tell you there, okay, now because I am very close to the answer, so I must give you
So
just a moment, guys. Let me calculate
6
this
to 5.
first.
So 62500 into 54 pi
Yeah, 54
divided
pi.
the cube root of that. So
Yeah, so it's 0.3333. It's 219 centimeters square. So you need a sheet of area roughly 220 centimeters square to make the scan. This is the minimum. Of course, some wastage will be there, some cutting off will be there, but with the help of molding process now, because we mold it, we don't make it manually. So we mold it and we mold into a given shape with the open can. The top is always open, which we cover with a lid actually separately. So you create a mold, you create the lid separately, and you fill the bottle, and then you cover with the lid. So that is how it is designed actually in the reality. And these things are very, very important concepts. So yes, you have to understand the marketing, the cost, and everything matters. So how much we are spending on this the material cost, and it will, if the cost will less, then of course the product will come cheaper to customer and they will consume more. That's the idea, right?
sir, does this means in the quadratic rest from the quadratic equation for the other type of equation, this types of solving is also there?
See, for every equation the process remains same to solve. If you're getting quadratic, it's easy one. If you're not getting quadratic, don't worry about it. What I can suggest, or what I can at least tell you, that most of the question will be up to cubic maximum. Maximum you can go to by quadratic, because they will always give you such equations which upon differentiation can be solved by student. So if something you cannot solve by simple manipulation, such question will never come to your examination. So don't worry about the complexity, although the complexity can go beyond your imagination. So that's very okay. Let's see this next one.
So why is the volume?
Pardon?
So why was the volume in the last question?
Okay, this is the answer.
So no, why was what? Why?
Why was
Volume.
volume?
So I'm asking that why? What did you consider why?
So why? So why is this much? Yeah.
So he's asking why is considered as volume, but
No, I haven't taken y as volume. Why is the height? Why is the height actually of the cylinder?
yes, sir, you substituted the value of y in the volume formula.
Yeah. So this is the y. Because what is the form of volume? Pi r square h. What is the volume of cylinder?
So no, that I understood.
Mhm.
Sir, I was asking, what did you, sir, can I write on this?
Yeah, you can write. Okay, after
Sir,
this,
that,
after this I went here, then I went here, and then I got this answer.
okay, sir. That.
Okay. So you might have seen the equation in that relation. That's why the problem is there. Actually, after y we have written the top equation, then below, then the last this is the last equation.
That.
All right, guys. So let's do some more interesting problem. Now, this is a very important problem. Even the answer of this problem should be remembered by all of you, because that's going to be coming very often. So we have questions like a sine x, which we learn in trigo also, b cos x. Let's say a and b are positive numbers. So we all know sine is less than 1 minus 1 to 1. Cos is also minus 1 to 1. So we know that sine and cos are very small values, which only go from here to here. Now I want to maximize y. What I can do? How to maximize y? So what value of we must choose the angle. What angle will give you the maximum value of y?
Sir, sir, you asked what value of x here, right?
Okay, do one just wait. I'll again do the my
No,
magical
I
graph.
didn't
Sir,
see
A
properly.
cos x should be equal to B cos x. B sin x, sorry.
So you will differentiate this. So if you differentiate differentiate this, what will you get?
Sir,
Sir,
we
a
will get
minus
A cos x
a
minus
cos x
B
minus
sin
b
x.
sin x.
B sin x.
Now equal to 0.
Sir, A
A
cos
cos x
x
is equal to
is
b
equal
sin
to
x.
B sin x.
So b sin x is a cos x. So sin by cos we can say tan x equals to how much?
A upon b.
That is what we are looking for. So we know that x, which is tan inverse a by b, this is the angle when y becomes maximum.
Yes, sir.
Yeah. If you differentiate once more, what will you get? The second derivative.
X square x is equal to A.
No, second derivative is
So what to
minus
derive?
a sin x. Differentiate this again.
Oh,
So minus a sin x minus b's cos x. Okay, you wrote.
So it's the same equation with negative sign,
Minus,
which
sir, it
means
will be minus y.
correct. So it's minus y. So I can say if we are solving it in the first quadrant, sin and cos are positive. So this is a negative number. If x lies from 0 to pi, if x lies from 0 to pi by 2, not pi. If x is okay. Let's say if x is from 0 to pi by 2 is the first quadrant, and we know that in first quadrant the sin and cos both are positive, and because both are positive, so positive plus positive is a positive number, but this minus will make it negative, and because it's negative, so what you're going to get is the maximum. So this is the way to say that what is the maximum value possible in the first quadrant. So what I can say now, so how to get the y max? Now we know that maximum will be at this location, at this angle. This is the critical point, you can say, at which the angle is maximum. But what is the maximum value of y? How to find this?
so putting that value in the.
Yeah.
Sir, we will put y f of tan inverse a by b.
Now, so we have to put like this. So don't put like that. It's written like this. A sin x is how much? For this angle, we have a triangle I have drawn here. And from here, you can find the sin x. What is sin x? What is sin of x from this triangle? Tell me, guys.
Sir, A
Sir,
upon
it will be
A square plus B square.
Very good. And what is cos x?
B upon
B upon A square plus B square.
A square plus B square.
Very good. So can you see that this is a square plus b square upon under root of, and this turns out to be same. This answer. So the maximum value of y, which you need to remember, is a square plus b square. Okay. So now, can I draw something like this? Okay. If I ask you what is y is given 3 sine x plus 4
Sir, but
cos
this is
x.
for the first quadrant. No?
Yeah. So in physics, we are only interested in the first one. Okay.
No, I didn't understood what you said about first and second quadrants.
Okay. What I said is the graph. If you know the trigo part, if it is taught to you, so you know the sign convention.
Yes, sir.
Yes,
The
sir.
first quadrant, sine and cos are both are all positive.
In second quadrant, sine and cosec are positive, and third tan cot, tan cot, and last one cos sec.
Correct. Correct. So if the angle is from 0 to 90, then everything is positive. So I can guess that the sum must be positive. So the second derivative must be negative.
Yes, sir.
And if second derivative is negative, so we are going to get the maximum or minima.
Maximum.
We are going to get the maxima, right?
So yes, sir. Understood.
Yeah, that's the
Less than
idea.
0, yeah, sir.
Okay, now imagine this question is given to you. You need not to solve at all. If I ask what is y max, what you can say?
Sir, it will be
Sir, here
of,
A is 3 sin x and B is
Yeah.
4 cos x.
of tan inverse.
No, the maximum value of y directly. This I am asking this answer, this question.
9 sin x square plus 16 cos x square under root.
No. We don't square cos and cos. We only square the coefficient. Come on.
9 sin x plus 16 cos x.
Arey yaar, come on, yaar. We don't square the sin cos. We square the coefficient.
Only coefficients. So 5.
Come on, guys. Where is the sin cos? So we are getting
So
5.
plus
5 is
or
the answer.
minus 5.
Yeah, we only take the value. 5 is the answer. Okay. Okay. What I'll do is I'll show you in the graph. You know, if you want to see the
Sir,
graph.
2 minutes. Yeah, 2 minutes. Sir, 2 minutes.
Okay. Just a moment. So let me start.
Sir, y max
Yes.
is nothing but the function of.
Yes. That is the maximum value of the function at that critical point called tan inverse x by tan inverse b by a.
Tan inverse by b. So, sir, we have to put value of sin x in the place of x. We have to put tan inverse a by b.
Correct. And if you solve, you'll get the answer. But
Yeah, sir.
because you don't know how to solve that inverse function, so you just remember the answer.
Okay, sir. Sir, 5, no? Answer will be.
Yes, 5 is the right answer.
Sir, for
I'll show you one more thing.
and 4 only, just for 3 and 4, right?
Yeah, just for 3 and 4, not for all values, of course.
Yeah, sir.
Just for 3 and 4. Okay, I'm drawing the graph and I'll share the screen just now. Just wait for 1 minute. And you can see it happening on, yeah. So, okay, it's initializing. Just a moment. Yes. All right. So now this is 3 sin x plus 4 cos x. Just a minute. Yeah, so we got this. No, it's fine.
Sir, are you writing something?
Yeah. No. Just a minute. I'm just going to share. Yes, this one. Okay, can you see this graph now? Maybe it's initializing.
Yes, sir. Now
Yes.
visible.
Yeah. So now this is the expression. You can see the expression is 3 sin x plus 4 cos x, and the graph is oscillating. You can see it's oscillating, but can you see the upper limit? Can you see the 5 here? The dot, the top dot.
Yes. And down also.
Yeah, down. So you can see it's going
Negative
east.
5, yes, sir.
Yeah.
In
So the maximum it can go, the farthest it can go is plus 5, and below it's minus 5. And the value we have calculated is for such expression, and it is looking like again sine function which is shifting right to left.
Sir,
Yes.
this is the way how we calculate the range for the
Yeah, right. Correct.
job sine. I mean trigonometric
Correct.
functions.
Correct. That is how we find the range also. So range is the upper limit and the lower limit. So you can say the range of this function is minus 5 to plus 5.
Plus 5.
yeah, sir.
Understood? So I hope that even the range question is not clear
So,
to you.
but range can be also find out without graph, right?
Yeah, of course. You want to see that question that we solve x plus y equals 10? You want to see that question? I'll just show
Yes,
you.
sir.
Look at this. So imagine we have expression as like 10 x into, it was, sorry, x into 10 minus x, right? But that was the question. So the sum of the two number is how much? Sum of two number is 10. So what is the maximum value? You want to see the maximum is 25? Do you remember? If the sum of two numbers is 10,
Yes, sir.
the maximum is 25. So let's see.
20.
Let's see. It's a quadratic. I'm just shrinking it. Yeah. Further. Yes, you can see now.
Yes, sir. It will be.
So you can see 25. Can you see that 25?
Yes, sir.
Yeah, sir.
You can see that if x will go from 0 to 10, at 5 it becomes maximum. Then again it will decrease to 0. I like it. So decrease. Yeah.
So
At
5 is the
10.
critical point, right?
Yeah. So 5 is the critical point because you can see the slope is 0. If you differentiate and you look at the tangent, you can also see the tangent is actually 0. So if you want to see anyone's maxima, let's say you can tell me other question which we have solved. Okay. What was the other question? Can you tell me the answer for other question? The expression. Just tell me the expression. I'll tell you the how it look like. Okay.
So the fence area one. Fence.
Yeah, fence. Yeah. So let's say for fence, let's say L is 20. Let's make it L 20. Okay. So I am taking L as 20. So the answer was okay. What was the expression? Just let me write down. Can you tell me the expression for the
It is 2x. Area was 2x. 2x
into
plus y.
no?
So
What was the area?
differentiated value.
No. Before differentiation, we don't have to differentiate at all.
XL plus 2x square.
Perimeter was 2x plus y and area was x into y.
I remember. Believe it. So see, this was the answer. So we had x equals to the area was x into 20 minus 2x. L was, I have taken L as 20, right? So answer was L by 4 and L by 2, right?
Yes.
L by 4 and L by 2.
L2.
Okay. So look at this.
So
I have
y would
got
be
this
10.
Yeah. So y will be 10 and x will be 5. Okay. So let's see the answer. Let's see the graph. Okay. I hope the graph will make sense to you. Something more. Yes. Now I can see. So can you see where the answer is maximum? You can see again the x is 5. Can you see x is 5, the height is maximum?
Yes, sir.
So x is 5. You can see the below graph. You can see 0 to 10. So maximum is at 5, right? Yeah. Can you see, guys? No.
Yes, sir. We can see, sir.
So you can see that at 5, the function attains the maximum. So the area, this is the area, this is the actual area. So area will be maximum when you choose x equals to 5. So x equals to 5 is nothing but 20 by 4. This is the answer which we had, L by 4. Right?
Yes.
Yeah, sir.
And y
So then
was,
L by 2.
And so y was
And y was 20 minus 2 into 5. So we have 10.
So it will be
It is exactly L by 2.
20 by 2, 10.
Yeah. So you can always see the graph is such a wonderful. Now, what we can see visually and what we are trying to solve is mathematically. So the visualization is too for your understanding that it is actually real thing. We are not doing something hypothetical. It's very much real. And the way to solve is the mathematical ways calculus will help you doing that. So that is the beauty of calculus. Okay, it will help you doing that. Okay. All right. So we'll go back. We'll go back to our actual board. Now, whenever you are solving question of maxima and minima, and if you want to verify your answer, you can plot the graph and you can see the maxima and minima in the graph, and that's pretty easy to decide your answer, whether it's correct or wrong. All right, so we'll go for something more interesting. The next problem is like, yeah. So let's say you make some kind of kulfi. You're a kulfi vendor. So you create a cone for your kulfi, right? So generally, kulfi vendor, what they do is they create a cone with a very thin base and the long length so that it looks bigger and still occupies the less volume. Yeah. But now you are trying to create a kind of conical container which can maximize the volume for a given area. Again, that is the same question as cylindrical question. So let's not do that question. Okay. Okay. So let me see the question. Just give you a question. Very interesting question I have. I have collection of questions. I have shared the question with you. No? You guys, the maximum minimum question. Just
So
no. Last class we shared no maximum minimum question. No.
so
Sir, you solved only one question.
Yeah. I solved the question. Okay, not to tell share.
yeah, sir.
Okay. Let me share it now. So this is the one of the most famous book across the world. Thomas Finney.
Sir, from Thomas Calculus.
Thomas, no?
Yes.
14th edition.
Yeah, this is what I have is the Thomas Finney, but you can buy the Thomas Calculus. That's fine. Okay, so I have sent you some questions. So which question you can solve? Yeah, that's nice. So check the question number 3. Or you can solve this question. That's very interesting, but that will be maybe okay, fine. So let's say you have a semicircle. Okay, I'm drawing the question. Maybe the first question I can draw this. So let me do this problem. So I give you a semicircle. And now you are supposed to inscribe a
So I got it. So.
yeah. So okay. The question is question number 2. Solve question number 2.
So from which book?
I have sent you the PDF on a group.
So I think I'm not received because I have just opened the group.
The
Okay.
rectangle is inscribed inside the
Yeah.
semicircle.
Right. Find the dimension of a rectangle of a greatest area that can be inscribed in a semicircle of radius r. Okay, I'll write the question. Find the dimensions of a rectangle of greatest area that can be inscribed.
So can we take the remaining value as x?
Yeah, you can choose whatever you want. You can choose variable as you wish. All right. So try this question, guys. I'm giving you 5 to 6 minutes to solve this question. Then I'll get back to you. I'm taking a break of 5 minutes.
Sir, please will you solve this one?
All right. So guys, any progress?
Sir, I'm not getting the.
Sir, I have calculated till the. Sir,
Yeah.
I have calculated first the length, then the area. Uh, After that, what
Okay,
should I
okay,
do?
okay. So do one, do one, do
Sir,
one.
I have differentiated.
Okay, anyone who is trying to solve this, first you draw a rectangle. Just draw a rectangle which is touching the this same circle. Just touching the. So you can draw something like this. You can draw like this,
So may I say what did I do?
and you have to maximize this area. You have to want to maximize this.
Hello, sir.
Yeah. Hello. Am I audible?
Sir, may I say what? Ah, yes, sir. Sir, may I say what did I do till now?
Pardon. Once again.
Sir, may I say what did I do till now? Where,
Yeah.
till where
Yeah.
did
Sure.
I?
Sure.
Sir, first I took the radius as r,
Yeah, that is
and
given.
then the remaining value as x. That after the rectangle, the remaining value as x.
What is the remaining value? What is the remaining value?
Sir, this one.
Oh, okay.
Yes, sir, so we can write it as pi r square. Sorry, pi r square by 2 minus the dimensions L into B.
Okay, so I'll tell you something better way of doing it. So you can say this is x, this is y. So area is simple, x into y. But area is not given, radius is given. So I can draw a line from the center to the edge, because every rectangle which you draw will have a symmetrical about its line, right? So this is x, this is y, so this will be how much? Y by 2, right?
So what did you do?
You draw a rectangle and the line, this is the line of symmetricity, this line.
Ah,
This is
yes,
the
sir,
line.
y by 2.
Yeah. So if the center of the circle is taken as the origin, you can see that the half of the rectangle is on the left and half is on the right.
Yeah, sir. So it will be by, yeah.
Y by 2. But the radius is always centered to the periphery. This is r. So we have a very beautiful relation in terms of x, y, and r. So we can write r square equals to x square plus
Y by 2.
Oh my God. So we got the answer which we're looking for. So we have the y or x, you can convert it either. So I can say y square by 4 is r square minus x square. So y square is
I
4.
answered it the same way, but I
Yes.
got stuck.
Just one. You will not get stuck. So that's not very difficult. So if you're going this way, you must get the answer. Now y I got as a function of x. That's it. And now my job is to substitute here. This is kind of difficult integration and differentiation, so I'll square it. When I square it, I know that it will be simple in terms of looking. It's not easy. Oh my God. Okay, so we have 4r square x square minus 4x power. That's interesting. Now you guys can tell me if area is maximum, then the square of the area will be also maximum.
Maximum.
So it doesn't matter whether you differentiate a or you differentiate a square. if eventually we have to equate to 0, so it's good to differentiate something which is easy for you to write. So we will differentiate a square by x, and then tell me what we will get. 4r square into 2x minus 16x cube, right? And
Yes,
it
sir.
really doesn't matter whether it is square or, because eventually we have to equal to 0, and that's my job is done. So what we'll get here after this, I'm writing here 8r square x minus 16x cube equals to 0. I can take 8x common. I get r square minus 2x square equals to 0, which will give you two answers. Either x is 0, which is not an acceptable answer. We can't take x equals to 0.
I also got x is equal to 0 first, then I cancelled all this.
Yeah, so just cancel. So what you can write is r square minus 2x square equals to 0. This will give you the good answer. So x will be r by root 2. That's a very beautiful answer. X is r by root 2. So we got the answer x. So what is y? What is y?
Across in India plus 9.7.
So r will be 2 into r. Sorry. So in the
Yeah.
terms of r only we will get now.
Yes.
Then it will be 2r.
2 under root of r square minus r square by 2, which is root 2r. Just
2r by root 2, no?
yeah.
Utilizing.
Happy birthday, लड़के. अरे यार. Okay, hello guys. So the y will be how much? Root 2y. Okay.
Sir,
Yes.
can you solve the way I did it? I mean, just ask.
Yeah. Tell me. How do you tell me?
Sir, I took the remaining value as r.
Okay.
Sorry, x.
Just a minute. So let me do it your way. And nothing wrong in it. So this is what you did. And you're saying you have taken this as x, right?
Yes, sir.
This is r minus x, correct?
Yes.
And this is r. The slant length, this is r.
Yes.
So the y we can get from here is r square minus r minus x whole square under root.
So can you show the previous verse for 1 minute?
Yeah.
Sir, can we do the whole thing which you send in PDF? Send it PDF.
Yeah, you can do a whole thing. That's not an issue.
Okay, sir.
Yeah.
So what did you do after differentiation
Yeah.
in the last
So
page?
now the thing is only about differentiation.
So after differentiation, what did you do?
After differentiation, we equal to 0. No, but I'll give you something very simple trick of solving this. You can solve in without doing any differentiation also. So there are tricks, and it's very easy.
So because I'm not getting the answer as after differentiation, I got area upon 4 times under root r minus x is equal to 0. So it will be 0.
No, see, you're getting the answer as this is r minus x. So what is your area? Your area will be twice of r minus x multiplied by y. So if you're solving the way you have said to me, then you will have expression like this, which is a plus b, which is 2r minus x, and a minus b is x, and then you have to differentiate this very complex kind of expression, which is why I will not recommend it. But I can give you something very easy to enjoy here. So let me look at this answer. This is like a breeze. Just blow your mind in no time. Now, in any circle, the biggest area of a square is when biggest area of a triangle is when it is a square. So in a circle, the biggest square you can draw is biggest area you can draw is when it is a square, and therefore the diameter of the circle will act as the diagonal of the square. That's simple answer. So
Yeah.
what is the side of the square? If I say A is the side,
Diagonal square equals to 2 into side square.
see the answer. I got the answer. So if I say side length is A, so diameter is how much? 2R. So diameter of a diagonal of a square is how much? Root 2A, if you know the basic math.
Yes, sir.
And this must be equal to 2R. This is R 2R, no? 2R. Come on.
Yes.
So what we got? A is, we got the answer. Because this is the Y. This is Y, right? And what is X now? X is very easy to find. This is X. What is X? Tell me. This is 45.
For-
So X is R cos 45, which is R by root 2.
By root 2.
We got the answer by doing nothing.
Yes.
And there is a third method. This is the second. We have third method as well. And because we want only for half, so you can just cut it half. It doesn't matter because what is true for the full is true for the half also. So my answer remains same, but I'll just remove this. So I'll give you the third method doing the same problem. This is very interesting. So we can do it by using just plain trigonometry. That's it. So plain trigonometry will give you the answer. How to get the answer with just trigo. So now what I will do is I'll use something a different approach. So if I say this is theta, what is the height, or this is x, what is x, what is y? So if r is the value, x is r sine theta and y will be 2r cos theta. Can we write like this?
Yes, sir.
So the area will be x into y, which is 2r square sine theta cos theta. So a will be r square sine 2 theta. So the maximum value of this will only happen when this is 1. Because the maximum of sine is 1. So sine 2 theta is 1, so 2 theta is 90 degrees, so theta is 45 degree, and my job is done. So I can say x is r sine 45 and y is 2r cos 45, and this will give you the same answer as we got earlier.
So what did you do? That maximum value should be 1 sine.
For the what is the maximum of sine angle? Sine of cos is maximum 1, right?
Yes, sir.
Yes.
And when the sine and cos will attach,
Yes, sir.
sine will be 1 when this is 1, right? This is 1.
So theta
And
will
see
be
which is the
45.
answer. So we got the answer in no time, and you can see this is the third way of doing the same problem. So of course calculus is one way, but many times we can solve question using the trigonometry.
This relation you found.
Sir, I want to take the photos for the last and the last page. Can you show them?
Sure, you can see it.
Sir, the relationship of x is equal to r cos
Last page
Yeah.
also.
equal to y by from polar correlation.
This relation you can get from the trigo, right? I mean sine cos. You can just
Correlation, no?
you can use this triangle.
Yo, okay, sir.
Sir, that last page.
Okay. This to this one, this one.
You give
Okay,
same
sir.
type of
Sir,
question.
done.
Okay, so now see, I mean, I have given you inspiration, like this is like a motivation, and you have to think about various ways of solving the same problem. So I have given you a sheet which you can apply the concept and you can get the answer. What you need to realize that maxima minima is something which is very very natural choice. Okay, so you start with some constraint which is given to you in the question. From the constraint, you derive the formula first. You make an expression, and once you have the expression, convert into one variable. And once you have the expression in one variable, then differentiate and go as per the rules of calculus. So if something,
Sir, so in short,
yeah,
sir, so in short, we have to first find a function, then we have to differentiate, then we have to equate to zero,
correct,
and then we can find.
correct. That is how we proceed. That is how we proceed to solve any question. Okay. Hello, hello, hello.
Yes,
Yes, sir.
Yeah. So anyone having any doubt?
no, sir.
Sir, yes, that you told you will solve that.
Yeah. So you can now start solving the question. We have done with the maximum, no? And you practice from that book, and then we will discuss the doubts if we have. And also one more thing that we are going to end lecture today now because some guest has come to my place. So I
Sir,
won't be able to
so you
continue.
will explain my doubt in the next lecture.
Yeah, sure. I'll take in the next one.
So
Yeah.
So that partial derivation.
Yes. I can
Okay.
take it in the next lecture. Not an issue. Yes.
Okay, sir.
Someone want to say something?
sir, at what point do we start differentiating? Matlab,
The moment you have the relation, let's say you want to maximize something. So something must be expressed in terms of one variable.
Sir, that variable should be equivalent to, means it should be means expressed in the form of both the variables, right?
Yeah, you can start with two variables, but you have to reduce to one variable by using the constant relation, like what is given.
Yeah.
And once you have the single variable expression, then you start differentiating, not before that. So once you have the expression which having only one variable, which may be x, which may be y, which may be theta, or normally it's like a habit that we choose x, but it is not necessary. You can choose y also, you can choose theta also, you can choose whatever you want to choose. But the moment you have that variable into your hand, then you can go on differentiating and then solve. The differentiation will begin that time.
Sir, and first we have to find function, then differentiate, then again we will differentiate, and the value is less than zero, so it is maximum.
Yeah, that will confirm. Yeah, that will whether it's maximum or minimum. Yeah, sure. Hello.
but in the we did a square. Usme to we had two variables. We had r and x.
R is not variable. R is given the question. We are finding the answer in terms of R, right?
Oh,
So,
yeah.
we are expressing the answer as R. So R is the constraint part.
So, sir, if they had given r, then we would be able to find the.
Yes.
Okay,
So
understood.
like you said,
Even
is
area would
where,
also we could find.
Yeah, go ahead. One
at
by one.
area. Sir, if you said that if a for area x and y, so it should be maximum. So a square also, for a square also, that should be maximum. So for every condition of a, it should be maximum, no? For any means
Yeah, exactly.
for
Even if you take a square root,
any,
it's maximum.
like under root or
Yeah, definitely. Any positive power must be maximum. Any positive power. The rule is any positive power. Okay. Any positive power.
so
The number.
under root will come out.
So you can't take, say, if a is maximum, then 1 by a will be minimum, right? So you must take the positive power. Like you must put a 1 by 2, 1 by 4, 1 by 6, whatever you can put, that should be positive. You're not supposed to put anything negative. You can't put minus
Sir,
half.
but if we put negative, sir, but if we put negative, then we will invert that to make it positive.
Correct. So if
Sir,
you know,
but it will be, means it will be
reverse.
calculate
Yeah,
the minimum value. So
correct. It will just calculate the reverse value. The maximum will become minima, and vice versa. Okay. So that's a simple rule. You must keep the power positive. Don't take the power negative. The best is avoid squaring and all. But if something is having too many roots or the cube roots, it's good to square and cube to get rid of the root and then differentiate the usual way, because that will be easier for you. Okay. Okay, guys. So we'll see in the next lecture. Till then, goodbye. Take care and do practice from the given
Thank you,
issues.
sir.
sir,
Okay.
please, are you going to, sir, now are you going to send the PDF of this?
I have already. Yeah, I'm going to send this. Yeah, for sure.
Yes,
For
sir.
sure. Okay.
Thank
Thank
you,
you,
sir.
sir.
Okay. Bye. Take care.